Welcome to the deep dive. It's still kind of amazing how AI seems to be popping up absolutely everywhere now.
Oh, definitely. From everyday stuff right up to transforming whole industries.
Exactly, like optimizing your schedule or, I don't know, helping write emails. But what's really caught my eye lately is game development.
Ah, yes.
I mean, imagine spending like hundreds, maybe thousands of hours on a game.
Years, sometime.
Right, years perfecting it. And then bam, some broken combo slips through or a rule loophole nobody saw.
The developer's nightmare. It can totally ruin the experience.
Totally. But what if AI could find those things before launch? And here's the really interesting bit I wanted to get into. It's not just digital games,
No, it's moving into physical games, too. Board games, card games, complex stuff.
which just seems unexpected somehow.
Well, yeah, it raises that central question, doesn't it? How can AI help in the physical game world beyond, maybe generating some art or powering a design website?
Okay, so what's the answer we're diving into?
The big one is AI as a playtesting tool. And it's pretty powerful.
Powerful how? Faster.
Faster, yes, but also deeper. It can simulate just countless matchups, find really obscure bugs.
Things human testers might miss.
Exactly. Or things that only show up after weeks of play, like weird meta imbalances. AI can surface those much, much quicker.
Okay, formidable is the right word then. So our mission for this deep dive, let's unpack how Google's LLM, Gemini, is actually being taught a trading card game.
Right, turning it into an AI playtesting partner.
The goal being to create a custom version, a gem, they call it.
Yeah, a personalized gem that can play the game, build its own competitive decks, even analyze matches.
And we're starting with phase one, which is what? The basics.
So pretty much. Phase one is core design, initial Gemini setup, so establishing the fundamental rules, getting an initial set of cards in there, and making sure the gem can actually, function for basic testing.
Okay, so you need to feed it the right information.
Oh, absolutely. And it's fascinating how detailed that setup has to be.
Yeah.
You need specific files to train the gem properly.
Like what kind of files?
Well, first, a guide on how Gemini should interact and show the game state, like cards on the field, discard piles, player health, all that.
Makes sense. Like a user interface guide almost.
Sort of, yeah.
Hmm.
Then, obviously, the full rule book. And crucially, the card databases.
All the cards in the set.
Yes. But, and this is important, without the flavor text.
Oh.
To save memory,
Hmm.
it keeps the AI's context window focused on gameplay data, not lore.
Ah, efficiency. Got it. What else?
General strategy guides, principles of good deck building, and this really unique thing called a CPU persona list.
CPU persona list, what does that do?
It simulates different human player tendencies, like programming one persona to be super aggressive, another to be really defensive or cautious.
Whoa, okay. So it's not just playing optimally, it's playing like different types of people.
Exactly. Which gives much richer feedback than just pure logic might. You see how different play styles interact with the game systems.
That's clever. Really clever. And it highlights how much data this needs, which brings us to a really practical point about these LLMs, something useful for you, the listener, to understand.
In the context window.
Right. Think of it like the AI's short-term memory, maybe, or like a whiteboard it uses.
Good analogy.
Yeah.
And everything you put in your prompts, the files, and everything the AI puts out, it's responses.
It all takes up space on that whiteboard.
Precisely. And when it's full, old stuff gets wiped to make room for new stuff.
So keeping those input files lean is key.
Absolutely crucial. That's why you might write your notes or card lists in Word or Excel, sure, but you upload them as simple.txt files or .csv files. Much lighter.
Even though a gem can handle, what, up to 10 file types?
Yeah, it can handle several, but lighter is always better for performance and keeping relevant info in context.
Okay, that makes total sense. So zooming out a bit, if AI can do this for complex games,
It makes you wonder, right? What other complex rule-based systems could benefit from this kind of AI analysis?
like what, business stuff?
Could be. Supply chain logistics.
Yeah, yeah.
Imagine optimizing those to avoid bottlenecks. Or city traffic simulations. Maybe even testing policy ideas to spot unintended consequences.
Wow. Stress testing policies, it's a big idea.
The potential to simulate and learn from countless scenarios is just huge. Transformative, really.
It really is. And just as a fun little detail to wrap up a nod to a certain classic card game,
Ah, I think I know where you're going.
the starter set for this TCG they're testing, it has exactly 151 cards.
Small chuckle.
Yeah.
That number definitely rings a bell for a lot of us.
Brings back some memories, right? So lots to think about here. What does this AI playtesting mean for how games get made in the future? And maybe more broadly, What other surprising things could AI do if we teach it the rules? What might you listening imagine?